tell me just a little bit about the steel and
This is the embrittlement problem.
the
The embrittlement
embrittlement
problem. How did you
problem.
know it was brittle?
Right.
Oh, before I returned to the Atomic Energy Commission, they ran tests, radiated tests, uh, hardness, tensile tests, and compact tests, and some of the engineers got really concerned. One of the things
This is on pressure vessel steels,
under pressure,
among other things.
right? Um, like the ships that were sinking during the war, traveling from the United States to Europe, and pressure vessels, they got concerned about crack propagation. When you get a defect and it starts, and the pressure vessel is under pressure and high temperatures, you can have catastrophic traveling crack. So when I came back to the Atomic Energy Commission, Joel Simmons,
His supervisor.
turned over the materials problems like at Oak Ridge, Argonne, Hanford, and many others, and that I was to address the pressure vessel problem. So I educated myself what took place while I was out of the nuclear business. Found out they had built these Army reactors and had them scattered in Greenland, and they had these radar up in northern Canada that they were monitoring possible strikes by the Russians if they got crazy. And they were hauling oil up there to supplies, which is very difficult. And so they thought they'd build one of these Army reactors, and then they wouldn't have to worry for long periods of time. But then when they found out the potential disaster they got worried, and that's where I walked in. And the nuclear reactor people, as I stated, were asking for plate thickness that were up to the maximum that the two producers of pressure vessel seals would be willing to qualify as quality steel. And if they were insisted on greater thickness to build these bigger reactors, that they would have to buy completely new equipment to process it. And that's where I came in. And I had a review at all Oak Ridge, Argonne, Hanford, and anybody else was doing pressure vessel steel R&D. And after a personal review to myself, I decided we were spending our R&D efforts concentrating in the wrong direction. And I felt sure that knowing the steel industry after being in it for 18 years, that the steel industry was using coal scrap, steel recycle in the remelting. And as I mentioned in our discussion, these impurities were climbing up gradually over the years. And I felt that's where our problem was involved. And fortunately, it turned out to be true that copper was a responsible one, making the embrittlement problem much worse, and phosphorus to some extent. And when we got together with the steel company, discussing it with their technical people, I asked them, could they do a study on what these elements were at different periods. And they were able to go back to as early as the 40s, 50s, 60s, and the first years in the 40s, the copper average 0.10%. And the next 10 years, it jumped up to 0.20%. And the next 10 years after that, at 30 years, it got up to 0.30. And when I came in, they were getting results going towards 0.40.
So it was very serious.
Very
by
serious.
the time you joined in.
And
So you
And then we found out that reactor manufacturers were building these vessels with weld rod copper coated. And that was a shock to us. Len Steele at Naval Research Lab and I were invited to a weld rod association meeting, and we listened to some of their committee meetings. And then we had a meeting with the subcommittee chairman and the chairman of the whole committee, and Len presented the results that we had gotten. And the first question they told us, my God, you didn't publish this data in a publication available to everybody. And they were shocked. They suggested we put the lid on it, and it was too late because it wasn't a classified program. And what I found out, the researchers, when they came up with something, the first thing they wanted to do is write a paper
And they did.
and have it publicized in a journal. So we learned a big lesson.
That's the lesson. I think that's one of the major lessons that you contributed to. I think you even feel that was one of your biggest accomplishments of your career. And I think we would all agree that this is a major issue.